Good evening, everyone. I'm going to call the Town Council special meeting of Tuesday, January 20th, 2026 to order. For those of you watching in the public or at home, this meeting is a joint meeting between the Board of Finance and the Town Council, which means the Board of Finance will need to call themselves to order. After the Town Council adjourns, the Board of Finance has other items of business that they will continue their meeting. But for now, Mr. Chair Ireland.
I'll go ahead and call this meeting of a special meeting for the Town of Cromwell Board of Finance to order at 5 o'clock.
Great, thank you, Mr. Chair.
Thank you.
With that said, let me just explain the evening's proceedings. About a couple of years ago, we did, our town engineer in coordination with others started to do some investigation into the Westfields. As you know, the Westfields has been a source of some consternation over the last few years. After that, we went ahead and used Weston and Sampson to do a larger engineering study of the location. And so this evening, they will be presenting to us different plans and their findings regarding the Woodside Intermediate School fields. There are not going to be any decisions made at tonight's meeting. There's no action items. Rather, this is an opportunity for all of the stakeholders to hear the information at the same time. So they'll give their presentation, and then the council and the Board of Finance will ask questions. Members of the public are encouraged during citizens' comments to also ask questions. And then the engineers will address what questions they can tonight, and then if there are residual questions they need to do further research on, they'll get back to us on. I want to thank the members of the Cromwell Little League, Cromwell Chill Soccer, and football team for attending as well. So that way everyone's hearing the information at the same time. So with that, I'll turn it over to our presenters.
My name is Ryan Chmielewski. I'm a licensed landscape architect in the state of Connecticut. I work for Weston and Sampson about 10-15 minutes up the road. I spent my life since 2020 designing sports facilities, public facilities, and focus most of my work in the public realm. Besides a landscape architect, I'm a dad of 2 boys that play soccer. I grew up playing soccer my entire life through college, and I was the president of Woodbury Bethlehem Youth Soccer for several years, leading the town in these types of decisions in terms of field usage, what does it mean for our groups, and so on and so forth. With me, I have Joe Perugini. Joe, you could raise your hand. He's a PE in Connecticut as well. He's our go-to for all of our athletic facility construction projects. And Evan Andrikos is also a landscape architect, project manager on this venture here. Next slide. So we just gave a brief introductions of ourselves. For those of you who are not familiar, Weston and Sampson has been in business since 1899. All of us in here have not lived that long. But the legacy continues with us. We're a fully employee-owned company. We're interdisciplinary, meaning we have engineering, environmental science, architecture, aquatics, any site and building type of profession you could think of. As I said, we're in Rocky Hill. We have about 100 staff there, and we're up and down the East Coast representing multiple states. So we're just going to give an overview of the site, what we found, hopefully educate a little people, a little bit about the site to people from a different perspective, and go over solutions. We have a few options to contemplate. Go over the basic project timeline. What does that mean in terms of construction length, permitting, timing, etc., and then open the floor to discussion. So Evan will walk you through the site.
Hello. As Ryan said, my name's Evan Andrikos. I'm going to take you through starting with the site overview. So you can see on the screen, we divided up the site into several fields for all intents and purposes. Overall field to the north, we call them Field 1. We have Field 2 further to the south. Field 3 and 4 are the diamond fields, and then what we're calling Area 5. These are Field 2 and Area 5 are the primary area of concern for the site. So here's what we know so far of the site, right? Historically, it was agriculturally used. There was removal of several feet of the soils and replaced with a fill material. You guys added dry wells, predominantly around field 1 and field 2. And then there is additional drainage with small diameter pipe to the south of field 4 that connects to the Woodside road drainage, existing drainage out there. The problem is you have long dry times on the field due to after a rain event. You have poor drainage with compacted soils, and which leads to downtimes on your fields in unplayable conditions. Some pictures that were sent to us of a recent rain event over here by your field house. You have an infield, some puddling at your infield area, and then at some of the existing structures out there as well. So when doing the site analysis, there's 3 main factors that we're going to look at. Your existing soil profile, which is going to consist of your root zone and your subsurface soils. Then we'll look at a slope analysis and look at your existing cross slopes of your fields. And from those, the soil profile and your slope analysis will help determine what kind of subsurface drainage would be needed. We'll use tools such as the if-then process and the renovation flow chart to help guide us. So, existing soil profile. In July of 2024, you guys got a geotech report done. You did about 8 test pits, which all dug to a depth of about 9 feet. You hit groundwater consistently around 7 to 8.5 feet, and with a topsoil layer of 5 to 6 inches, which included about a fine to medium sand. You had fill material 2 to 3.5 feet, which was a glacial till material. And then below that, you had your native soils. In October of 2025, Weston and Sampson went out and we did infiltration testing of your topsoil. We did a 30-minute pre-soak, and concluded with 0 to about 4 inches per hour of infiltration. We sent soil samples for analysis, and it concluded you had a sandy loam with about 6% gravel on your topsoil.
If you could just use the mic, I'm sorry. Thank you. Yeah.
The sandy loam really means that you have some fine soils, clay and silt, as well as we tested the soil according to American Sports Builders guidance and broke the sand fraction down to very fine and fine sands. Because if you have a high percentage of those fine sands, it could also choke up your soils. So not only do you have some silts and clays, you do have very fine and very fine sands that are out of range. It's not the end of the world. It requires a lot of maintenance annually and multiple times a year annually to decompact and core aerate, but it's very susceptible to compaction with overuse. And with that compaction comes poor drainage.
So next we looked at your slope analysis of your existing fields. Fields 1, you can see pitched in this direction with less than 1% slope. Field 2, you had a crown in the middle and you pitched in 2 directions towards those dry wells, and you are anywhere between 0 and 0.5%. 3 and 4 were consistent, less than 1%, pitching towards the center of the field, area 5 here, which leads us to believe those area of concerns. You can also tell by the blue arrows that you are basically in a bowl. So you're collecting all of the runoff and coming off the side from this slope here and all around the site. And this goes back to the one of the tools we would use, the surface slope chart that we would help guide us, and there's more to come on that. Another analysis we did, we threw it into CAD. And this is a great little diagram to help show you, identify some of those percent slopes. So again, mostly you're gonna see you're in the yellow in the predominant areas of play here for field 1 and 2. You do have some green around the outskirts, but where you're actually playing on the fields, you're less than ideal, less than 1%. And Joe's going to talk a little bit about your existing drainage.
Good evening, Joe Perugini. I'll just speak briefly on some of the drainage we observed. We did visit the site to inspect what was currently there. It's a combination of yard drains and dry wells. Some of the photos on the left are the dry wells. So those are structures that have openings within them. They were intended to drain the surface runoff and allow some infiltration into the subsurface. The problem with those, as a lot of folks know, they tend to clog up over time. If fine sediment gets into them, the fine sediment will settle out and clog the bottom of them, and they tend to fail over time. So you can see there's some water that has built up in one of the photos. That's either groundwater or just the fact that it could not infiltrate further. And then some of the other structures, it was a combination of they don't have sumps that could allow for sediment buildup, and just overall poor construction. This is just a brief diagram of the existing drainage or site. Woodside is on the bottom of the page, North is to the left, and Gear Street is on the left. We highlighted the existing drainage systems in that light blue cyan, and we put a dashed line around the existing system that drains out to Woodside and beyond. Just looking at some of the information we had on that system, it looked very flat, the pipes in the road and that extend into the site. The fields themselves and the topography are such that they're in a hole basically, so they're lower than everything surrounding it. They're lower than Gear Street, lower than Woodside, and I think we believe the intent was that the drainage would percolate or infiltrate as best it could, but perhaps overflow into that roadway drainage that's surrounded or highlighted with the dashed line work. Based on some of the information we reviewed on that pipe system, it doesn't appear that it could overflow very well. The pipes are very flat, and there's a possibility, without doing an analysis on that system, that system could already be overloaded with all the runoff from the school site and what is in the road. So a lot of times with these sites, we want to look for relief. Where could the runoff drain to? We don't believe we have that ability to do so because there is no off-site relief for that. This slide here shows what we're proposing to store the runoff. And I know it's a little busy with line work, but again, this is rotated so North is to the left and Woodside is at the bottom of your page. We highlighted the existing dry wells in red because those are in locations where the site currently drains to, and we're looking to store the runoff. So if we have a large storm event for varying storm events, we're looking to provide a location for it to drain down to. And one of the solutions we come up with is using a chamber system. You can see it in yellow. These are arch type chambers. They're surrounded in stone, and then the stone is wrapped in a filter fabric. So this creates quite a bit of storage underground. It can support even driving over them, but this creates a fair amount of storage so that when you have a large storm event, it gives it a place to go. And we looked at some of the geotechnical boring and subsurface surface analysis to look at how deep we can go with this system. So it appears that we have a better native soils down at around the 4-foot depth. It varies because the site is not all flat, but we selected a suitable depth at which we can store as much runoff as we could, but we're also looking to balance what is a reasonable storm event and amount of runoff. So the very dark line work that you see there, we had located these chambers. In some cases, on some sites, you'll see them grouped together in a series of rows in a grid, but we thought, why just add pipe work? Let's use the chambers as a series of pipes and extend them to connect all of the dry wells. And it's also a good location to connect the field drainage. It may be difficult for folks to see the detail on the left, but that's kind of a cross-section view of the chamber surrounded in stone, but coming from above at an angle is a small perforated pipe, and that's where the field drainage would tie in. And I'll hand things over to Evan on talk about the field drainage.
Thank you. So yeah, so I think as we get into the solutions here and the options moving forward, I think it's just important to note that each one of these options are going to require a certain amount of stormwater management, like Joe was saying. So the chambers outlined around field 2 here would be a solution, but the laterals at each of these fields are really going to depend on which options we go with, okay? So option 1 is what's called the sand cap buildup system. So the sand cap buildup system is a system set forth by the Michigan State University. Set forth by professors at Michigan State University. It was, yes, thank you. It's a tried and true method, which consists of top dressing and addressing any of your immediate low spots. You're gonna core aerate and you're gonna pull plugs. You're gonna fill those holes with sand, and then you start what's called an 8-week renovation plan, where you're gonna continue to top dress with sand or root zone mix, and continue up with mowing and fertilization up to about 2 inches, and you can continue as needed. But what this does is it allows you to keeps your fields, they don't have heavy renovations, and it allows you to just continue the grass to grow in place while you're adding and you're amending your root zone. It's the least expensive option, least amount of downtime, and you can continue until you reach your desired results. So here's just a cross-section of what that would look like.
Part of this solution too is that you're utilizing the existing subsoils for their water holding capacity. So while you get good surface drainage during playing events, it's about 2 inches of it, and then the drains are intended to carry off water at a faster rate. And it also minimizes your downtime, like Evan had said.
So here's just a few images of what that might look like. You can see the grass is still green, you're just top dressing, and there's no heavy renovations going on out here.
Evan, how long of a period after you're done with the sand you have to let it grow in?
So after you're done top dressing, after your 8-week program, it's probably good to at least a month to let it establish before you get any playability on there. But it's the shortest amount of time of these options. So option 2 is what's called the partial field reconstruction, where we're actually going to strip and dispose 3 inches. We're going to cut in your drainage laterals like we talked about, and we're going to top dress with sand. From there, we're going to do something called bleckavation, which is basically a rototill, where you're going to amend down to an 8-inch profile to create your root zone with what you're looking for, your 8-inch profile. It's going to need irrigation repairs, and this option we're currently holding pricing for a sod to just again to keep the downtime to a minimum. It's moderate costs, moderate downtime with like a 6 to 9 month window is what you're looking at.
If you look at the picture in the back, there's the bucket loader with a machine on the back. That's called a whiz wheel. It makes nice clean cuts and drags drainage lines behind, so it's an efficient way of construction. Part of this construction is when you blend on site, you're adding that 5 inches of sand on top. That's based on the soil analysis that we had before, and we look at how much do we need to cut the sand fraction in that root zone in order for that to drain properly. Some of the drawbacks potentially are consistency of the blending. You could do several passes in different directions, but it's called marbling. If you like a marbled rye bread, you have those swirls in that rye bread. Well, the same thing could happen with when you blend the soil. And the next option, it's going to be a more controlled environment to get that growing medium.
And again, just a few pictures of what that might look like, where you're stripping off your turf, you're adding your sand, and then you're bleckavating or rototilling that in to create your profile. Our last option here, option 3, is full depth reconstruction. You strip and dispose 12-inch depth of material. You establish your subgrade so you can get proper pitch on your fields. You're going to add a 4-inch gravel layer, your 8-inch root zone, new irrigation, and then this option we're currently holding seed for turf establishment. So it's going to yield the best results. It's obviously the higher cost margin and the longest downtime.
Some of the advantage to that, so Evan, if you go back a slide, with this option, it's ideal in a construction world for athletic facilities and even for general lawns at your home. Your subgrade should really match your finished grade. So the other two options, we use under drains to manage that soil profile, as do we here, but we're not correcting the subgrade. This option is really a belt and suspenders. The soil mixture that you put down, we could either utilize on site and have it blended on site with imported sand, or we have it mixed at a custom soils place and they deliver. It's pretty common in different areas for sports facilities, especially when you want high performing athletic facilities.
Again, just a few pictures showing the full depth renovation, your drainage, cutting in your drainage system, and it's a pretty heavy operation out there. So in summary, option 1, your sand cap buildup system, approximately $1.5 million for the site with a 4 to 6 month timeline. Option 2 would be a partial field reconstruction, approximately $2.4 million with a 6 to 9 month timeline, or option 3, full depth reconstruction, approximately just over $3 million with 18 to 24 month timeline, depending on seed or sod, and all these have some variables to those.
Right, so the option 3 with seed, you basically, the ideal time the seed is in the fall. So you have 2 uninterrupted weed seasons, fall and spring, to get a good stand of grass established. We recommend holding off to the following fall to actually get sports use out of it, because it is pretty rigorous. Whereas if you could potentially do sod on the field, that has pluses and minuses. There's a cost, but sometimes the contractors prefer to put sod down. It's a lot less time establishment and a lot less work for them. So it's not a linear trade-off in terms of dollars. As well as there's some follow-up, depending on the sod type you could get harvested. We want to match it up as best as possible to that root zone. And then there's some post-establishment work that needs to be done, so you're not forming a hydraulic cap on the field where water can't penetrate through.
Then just a quick example project of one of our most recent projects we did. It jumped over. There it is. This is out at Springfield International Charter School. That was a full depth reconstruction field we did out there, and you can see the results look great after the fact. They're able to get on the field right after a rain event. those are just some pictures of that. And then basic project timeline. So in 2025, we finished up preliminary analysis. We're currently at our site design. You know, pending on which option we move forward with, we'll push forward with construction documents in about a 3-month time frame. And then again, pending which option we move forward with for the construction period, anywhere from 6 to 24 months.
Alrighty. Anything else to add before we go to questions?
Yeah, a couple things. One is, it seems like a large dollar value, and there's a lot of square footage of fields. There's two basically full-size rectangular fields, and then two 60-foot diamonds for baseball, softball. And then plus we have some area renovation in the center around the kick wall. Plus your more of the drainage infrastructure to help support can add up as well. I think that was it.
Great. So with that, what I'll do is I'll open it up to the council and the board members for questions, and then I'll move into citizens' comments after that. If you want to address the questions as they come, or if you want to wait till the end, I'll defer to you guys as the experts. But I'll open up a question for board members and for counselors. If anyone wants to start the ball.
Okay.
Okay, John, go ahead.
All right, I guess I'll jump in first. First, thank you. Appreciate you coming tonight. Appreciate the info. And I don't know, does someone still have control over it if I ask for a certain slide or something?
Yeah.
Is that right?
Yep.
Because I only
We
have
have till 7.
I only have about 14 of them. There was talked about like what the certain footage and dimensions ended up being of the current soil there. The geotech report there. I'm just out of curiosity, for those top lines there, the measurements there, for a field that we have here that gets the use it gets, that is looking to have it do what we want to do. I mean, how far off? I guess my question is, are those numbers? Like, what would you want to see out of that? Like, how bad is it versus what you'd want to see for a playing surface that we're looking for? Does that make sense?
Yeah, so for any athletic field, we would propose nothing less than 8 inches, number one.
You talking the topsoil?
Topsoil.
Okay.
Groundwater is down pretty far. However, we don't know if that was impacted by the subsoils, the glacial till materials that were brought in after removal based on the school construction. So for the remediation of the site, they removed 4 feet. They put back 4 feet over the top of beautiful sand below, but it's glacial till, which means it's super fine soils and compacts like rock. So that's very bad for fields below. That was basically what was at Springfield International Charter School in Springfield, right up the road. It was impenetrable. It didn't drain at all. So in an ideal world, you have good draining subsoils and reasonably well-drained topsoil or root zone mix. So
Can I ask a
we're
question,
getting,
John?
the depth of groundwater during the geotech, you could see it was during July 2024. That is out of the seasonal high groundwater table, which we're going to start approaching soon in February to May. So as part of this project, we proposed doing some exploratory test pits to verify that depth of groundwater during seasonal high groundwater.
So you're anticipating that the numbers are probably actually worse than what we're seeing here, just because when they were taken?
Possibly.
Okay. Sorry, Jack. Go ahead.
No, it's fine. Right at the beginning of the presentation, you said something about 6% gravel is what was found. So my question on that is, what percent of gravel should we have there? Would have been appropriate, 8 or more?
Gravel just helps us understand the composition. In an ideal world, there'd be very low gravel.
Low, so a couple inches, 3, 5?
Well, no, so if you look at that picture on the right, You could see the gravel, there's like 3/4 inch stone mixed in within the soil. From an ideal world for maintenance, those rocks eventually will work their way up. You want a homogeneous root zone, like a sand-based loamy sand, not a sandy loam with gravel in it. So I'd have to go back. There's a specific chart we utilize, an ASTM standard for that gravel, and it wants to be below threshold, so I'll have to follow up with that percentage.
So a good amount of it has to be removed.
Yeah, it would have to be screened out.
Yeah, so be replaced, et cetera. Okay.
So let me just, I think they're both asking the same question from different perspectives. What is the ideal composition that the soil should be? Like, what is the sweet spot? What is the golden ratio?
There's $1 million question right there. And a lot of it has to do with expectations and how much maintenance the town has to put into the fields. It's not a straightforward answer. On typical fields, we try to do a blend between the high-performing root zone mix, which requires, it's basically a sand-based root zone that requires 10 inches of drainage per hour or more. And there's a native soil ASTM standard that requires greater than like 0.5 inches or 2 inches an hour. So we like to try to get a soil range that it drains within 4 to 8 inches per hour, and that's more of a reasonable approach. And if you think about 4 or 8 inches an hour, if you get a 6-inch rain thunderstorm, all that water's gone within an hour and a half. So it goes pretty quickly, so the return on play is quicker and less susceptible to rainouts, etc.
Okay. Go ahead, Dan.
Yes, so just understanding the three options, is that the biggest difference, the biggest advantage of spending more money is lower maintenance, return to playability? I can't understand going from your first option to your third option. What's the big difference between those three options that we could make a decision as to how much money we want to spend, how much time we want to take these fields offline?
The biggest difference between the two, there's a couple. One is the subgrade is being corrected in option 3. So and you have the ability to put a little bit more pitch on the fields. If you have a true high-performing sand-based root zone, 0.5% is fine, but to maintain a 0.5% on municipal dollars is rather challenging. So we had the high-performing root zone at Sabas International Charter School, Springfield International Charter School now, and that was graded at like 1.25% to 1.5%, and it performs well. The second thing is you're getting.
I'm sorry. Before you go on from that, explain that in the terms of what does that mean to the town? Like the fact that you've now improved it to that level, does that mean lower maintenance, return to playability? I'm trying to get a sense as to what the elements are that we're trying to solve for here. That's going to say we want to spend $3 million versus we only want to spend $1.5 million.
Yeah.
What would drive us to a decision to spend more money and take these fields offline for 2 years? Because that's going to be a gut-wrenching decision, right? The amount of money, but in particular, how long those fields are going to be sitting there not used.
Right.
Why would we want to do that?
The second reason is the soil is blended off-site in a controlled environment where you're importing brand new soil to the site. You're not relying on your existing soils at all, and it has a much more controlled environment and less variable.
So let me try to ask Dan's question in a different way, right? Option 1, option 2, option 3. If we have a 3-inch rainstorm, how likely is it in option 1 playability is the next day, option 2, option 3, right? Because the issue that we have is because this is a bowl, because the pitches aren't right, and we have 2 problems, right? The pitch isn't right, and there's clay and other materials that don't let things drain. I'm a layman. Those are the 2 issues.
Yep.
How do each of those issues how do each of the solutions address those issues? And then in turn, what is the both the bounce back time for usability and then maintenance time for, if we do option one, do we need to be spending $1 million every 10 years to get it returned to this condition? Or is it, versus option three, which is just regular cleaning and maintenance and you don't have to touch it again? Right? So I think, right, we have to think about a lot of moving parts, right? So I think we're just looking for the pros, and then we know what the cons are. But with the pros for each of them being, bounce back time and then maintenance time and cost savings. I think that's what Dan was asking.
Yeah, so the root zone in option three will require, you'll have a stronger stand of grass, which is more resistant to wear and tear, because you have a separation of any water that may collect on the bottom. It won't form an anaerobic condition, meaning the roots won't sit in a wet environment and potentially have root rot and have a very low density of the amount of roots underneath that grass. That's the main advantage right there.
And so let's just pull the thread a little bit more. Talk maintenance and what you would expect a bounce back time would be for, like, let's just say a 2 or 3 inch storm under each of the options.
All of the options would have a similar bounce back time because we're adding the under drainage. The other advantage of the option three is that we could space the storm drain lines, the under drains, at 15 to 20 or 25 feet from each other, so it's less drainage infrastructure because you have that consistent subgrade.
So let me make sure I just understand. All 3 options would involve those chambers that you showed the cross section of being installed?
Correct.
So in all 3 options, the chambers are installed, which is the core, I'm assuming is the core part of the cost is bore. Do you have to bore for those and insert? How do you get those?
No, those are just excavated.
Okay.
Yep.
Okay. So that's the majority of the base cost, and then everything else is what do you put on top to make those actually useful?
Correct.
Okay.
Has,
Ed, then Brian.
Follow that. Is it
putting myself on, is it when you say don't have to excavate, my understand, and this is not my area of expertise. My understanding is the biggest problem that has been caused, in addition to the fact that it's simply low, is that the materials that were added during construction that replaced the natural soil were a problem in and of themselves. Well, they're sitting there. So aren't we in, my understanding is the difference between 1 and 3, at least, is you're not getting rid of them in 1. You're just leaving them there, right?
We are leaving the soils in place in 1 and 2.
Right. So when we say put the chambers in, are you putting them in at the same level in all 3? Or
No, so the chambers are probably taller than I am,
okay,
and they get excavated down, so they're buried below grade. If anyone go to that.
well, this is what I'm trying, and here's,
Right.
again, I'm a layman, but here's my failure to understand this. If you excavate everything down, let's say they're 6 feet tall, I assume that means the bottom of them is 8 to 10 or more feet below grade. Then don't you have to take out that existing, I mean, they're taking the place of something.
Only where the chambers are going, though, not the entire surface of the field and undersurface of the field. Only where the chambers are being placed is what will be removed.
Correct, so you see those
Okay.
6 red dots there,
Right,
and there's dark blue lines in that horseshoe pattern that connect them.
right.
That's a linear row of those chambers, so it's not the entire field.
How long are the chambers? When we say chambers, are they,
I'll let the civil engineer answer.
okay.
It's about 1,000 feet, linear feet.
No, but what I'm saying is, we saw a picture, there's a picture in there somewhere, and I'm sorry, we never saw any of these materials until, 20 minutes ago, so we're making it up as we go along. It looked like they were rows of pipes.
Right, are you talking about the
Right.
photo in yellow?
Yeah, that looks like 20 pipes next to each other to me. Am I-
Yeah, apologies for that. That's an example.
Yeah.
These, that's what a typical system is,
Right.
where they're lined up row by row.
Right,
Rather than bunch them up in one location, we're running the chambers in that horseshoe, linear fashion, so that we
Oh.
don't- yeah, we're actually extending the chambers closer to the fields and the under drains, so that they can all tie in. So we don't need to create a footprint with several rows like the photo. That's just an example of what a chamber looks like in a photo view.
okay, so, that makes me slightly more confused. So let's call the area inside that horseshoe the field.
Yes, it is.
As the water comes down on the field, how does it get to the pipe?
Pitch.
Gravity.
Why does it go sideways, is I guess what I'm saying.
Water
Why does it-
runs from places of high to places of low.
Right. Water will always run downhill.
Right,
So the pitch of the field will direct the water.
So you're saying that that's already
If
in
we-
place?
Right, there's pitch now. You can see it's around a little under 1% on field one. That means for every 100 feet long, the field drops 1 foot in elevation. So that
Okay.
forms your slope.
so you're going to duplicate the current crown, I guess, of the field.
In scenarios 1 and 2, we would
Yeah.
be maintaining the same exact crown and configuration of the surface grades.
Okay,
Yeah, so it's for the water to go. The only difference is we're amending the topsoil to have more sand in it, so water could get through to under drains, which are different than the chambers. Those
Yeah.
are just small little 2-inch pipes that have perforations in them
Right.
that collect the water and lead that water into those chambers.
okay,
So the original chamber diagram that you saw them stacked next to one another
right,
on the bottom left,
yeah,
that was an athletic facility used for infrastructure. It was an overall storm drain infrastructure to relieve flooding in a downtown area. So we used the athletic facility, the soccer fields, we excavated out the full field that 4 or 6 feet in depth, put the gravel and chambers in, and replaced it with a sports field on top. That's the difference here.
That's what we have at the middle school.
Yeah.
okay,
So here, we're only proposing a linear row in that horseshoe fashion, so they're connected end to end to each other.
okay,
And they form basically a pipe.
okay.
So in option 3, you're gonna change the pitch?
Option 3, we'll explore changing the pitch so you have consistent drainage over your entire facility. In this diagram, you could see the field 1, where it says 13 feet tip. That means the under drains, the 2 to 4 inch pipes, are spaced every 13 feet. That's because you have up to a 1% pitch. The lower field is 0 to 0.5% pitch. In the bottom right-hand corner, it barely pitches at all. So there, we had to space those under drains at 6 feet on center. So during the process, this type of construction in option 1, where we're just cutting in the drain lines and sand cap, I was down in Camden Yards, baseball field in Baltimore, for an American Sports Builders Conference, and they walked us through some of the renovations, and the whole field was torn up. It just looked like complete sand. It looked like junk. And we said, well, what the heck is going on here? And they basically went through and did a agricultural maintenance to it by incorporating more sand and top dressing. So that's similar. It'll be a disaster look for that probably 8 weeks in time until it starts to grow up and then finally establish final grass. That's option 1.
Okay, Brian.
With all of the excavation and and whatnot, has anyone taken into account the current irrigation system and the removal of and replacement? Is that in part of the cost? Is that all included in the cost of these projects?
Yes.
Okay.
Other questions? Mr. DeProto?
Hi, thanks for coming in. Quick, easy question, I think. You said that these storm tech chambers or whatever they are, they can be driven over by vehicles or? Okay,
That's correct.
okay. Okay, so, and then on options 1 and 2, you said that basically we're gonna keep most of our existing soil, you're gonna mix in some stuff. So I'm just a little bit curious. I mean, again, like Ed, this isn't my specialty. The current problem is that one of the current problems is the dry wells are getting plugged up by the small particle sand or whatever. So that soil's still around. Won't it still plug these storm tech chambers as well, or is that some different kind of?
Yeah, the difference is these storm tech chambers, in that detail you see there on the left, the chamber is that arch shape, and those are surrounded by crushed stone, and then beyond the stone is surrounded by a filter fabric. So as water enters the system from that small diameter pipe on the upper left, that's the field drainage. As that enters the system, there won't be any plugging. It's going to be filtered by the time it gets into the system. So you're not having that issue of surface runoff and sediment being carried into the system. So as surface runoff works its way through the soil and into the field drainage, those small diameter pipes, it's basically getting filtered so that you don't have that issue of, usually with surface runoff, area drains, as it's carrying fine sediment over time.
So what you're saying is this stuff up here, that's going to be the fine sand will be gone, and that's where our drainage pipes go, and then they go down to this subterranean structure that. Okay.
That's correct. The surface runoff is going to get filtered. It can't carry sediment down into that small diameter pipe that is lined throughout the fields. So it'll be naturally filtered by the time it gets into the system.
Just to, Jim, and I'm sorry to interrupt, just to piggyback on that for a second. So will there need to be like mucking out or cleaning out of these smaller diameter pipes, or will it naturally, okay, so I'm seeing a nod, so okay.
That's correct.
Go ahead, sorry.
No, I was going to say thank you. That clarifies things greatly.
Okay,
These systems do have the ability to be cleaned. At each end, they can run a jet vac up one side and pull it with a hose, and they have the ability to be maintained. We're not anticipating that. If this was a pavement parking lot where you're getting a lot of runoff, you'd want to isolate that sediment. But if it were to get into these systems with a parking lot type system, they can be cleaned. We're not anticipating it for this type of application.
I just wanted other clarification, because this is the first meeting I've been involved with on the field thing. Can you go back to the slide where it shows which the fields were numbered? It was fairly early on. All right, yeah, that works. So which fields are being worked on? Is it field 2 and area 5? What is going to be included in this?
1 through 5.
All 4. Oh, wow. The whole thing? Okay. So,
Maybe I don't understand that. So if the horseshoe is going around field 2, and then you're going to need to be putting in the feeder pipes in field 4, so how, the excavation area is just going to be field 2. How are fields 3 and 4 being impacted? Because I don't see the horseshoe over there.
So if you look at those diagrams here, we have 13 feet on center for the under drains in the grass field areas, and there's a collector pipe on the edge that eventually ties into the system over here. And then same thing here, this collector pipe system drains all the way down and ties into the horseshoe over here.
That will need to be excavated as well. Got it.
Yep.
Okay, other questions from the group? Mr. Maley?
So, these are all coming down to the lowest point on the ground, obviously, it's all gravity. Where's it going from there?
So the chambers will be able to hold up to a 50-year storm, we estimate. That's
Right.
about a 7-inch rainfall.
Right.
And the depth of those, we used all the available information to determine where was the highest recorded groundwater elevation. So these chambers are above that,
Right.
but they're low enough, as low as we can go to get some infiltration.
Right.
So we then take the infiltration rate
Yeah.
that was provided by the consultant that in 2024 that did the analysis. We reduced that by a factor of safety, and we base the infiltration. The system will fully infiltrate based on that rate. So it's going to infiltrate naturally because we are not relying on its ability to overflow into the school system that goes out to Woodside. We believe that that may be a source or an issue that it has not been able to overflow based on those storm events that were shown. So it's relying on the ability to store it and get it underground.
Right.
It'll fully hold that, and then it will infiltrate down to there are below the fill soil
Yeah.
that we've been talking about that was an issue. Those chambers are set down at native soils where the infiltration rates were determined and tested to be better.
So let me put it in my layman's terms. The water that would otherwise be collecting on the surface is now collecting in these pipes below.
That's correct.
And these pipes they themselves drain into the natural soil.
Yes.
And they go 100% out through groundwater, no flow, just down as opposed to sideways somewhere.
Well, groundwater will flow.
Flow
laterally.
eventually, yeah.
That's
right.
how it
But
continues.
it's going essentially downward from where it's starting and then out into the world. Any discussions with the water district about their thoughts on this?
Well, we've been discussing this with engineering.
And in the water district who runs the unfortunately in this town, the water district is not part of the town. But they provide water to the town.
We're not in an aquifer protection area.
This is not in the aquifer protection zone.
Yeah.
No part of it.
No, we're a good distance away from that.
Okay.
Yep.
I have a question.
Jack Benjamin.
Life expectancy of the chambers of underground there?
Oh,
Is that-
decades, many decades, yeah.
You say decades, we're
We think
we have buildings in this town that are more than decades old. So are we talking like,
We're looking for 100
are we
years.
looking at 20 years, we have to do it again? Or are we looking at like 50 years, we're gonna have to do this again? Or 100 years and I'm dead and somebody else has to do it again?
I just wanted to, John Harriman, town engineer, I just wanted to say that these chambers are all over town. Developers are putting these in all over. Most recently, the Landon up at the top of the hill, all of those parking lots drain into chambers exactly like these. They're not actually pipes, they're open bottom. They're, you know,
Oh, they are
So,
open bottom.
so they contain a large volume of water. The stone outside of them also contains water, a large volume, but they infiltrate into the ground. And like they said, the infiltration rates in the soils that were brought there on site were in '24 measured to be inches per day, sometimes close to 0. Whereas the subsoils, the natural beautiful sand, gravel underneath, was in feet per day. So it's just a matter of getting this water from the surface where it's mostly evaporating today. It's not really infiltrating, it's mostly evaporating, and getting it into those good soils and make it disappear. And I 100% concur with their analysis that the surrounding drainage system for the Woodside area, which includes all of those new subdivisions like Kirby and drawing a blank on all the names, but they all drain into relatively flat pipes, which are a little bit higher than where we are, and they all go out behind the Lutheran church there behind Kirby into a discharge point, which further downstream becomes all flood zone. So it's in our best interest to get this stuff into the soil, and I feel that this is probably the best way to do it.
Great, thank you.
Thank you. And then Mr. DeProto.
Thank you. On option 3, the price you've kind of quoted here, that's considering just doing a normal planting of grass seed and going through the seasons to get it back up to full strength. But then you also mentioned there was a turf option. Do you know how that might impact that timeline and what additional costs that might incur?
You will get quicker, immediate establishment of grass because you're bringing in live cut grass and placing it on soil. The difference between a seeded stand of grass and the sod that's cut in a farm somewhere else is that they're different growing medium. So seed on the soil that we put out there will naturalize and grow within that medium, so it will adapt to it much quicker. The sod is a more instantaneous use. It generally needs 6 to 8 weeks before you could start play on it, and it's a much quicker turnaround time. Now the cost is, we could provide that cost as a follow-up for sod, but a lot of times contractors will wait, just like at Springfield International Charter School, it was originally intended for seed, and the contractor just wanted to do his job, get out, and move on to the next project. So the sod, he gave a very aggressive price on sodding, knowing that he didn't have to maintain for a full year.
Thank you.
Any other questions from the council or from the Board of Finance? Hearing none, I will now open it up to citizens' comments. If members of the public wish to address the engineering team, just please state your name and your mailing address. If you're on behalf of an organization, you can state the organization's mailing address. If you're here as an individual member of the public, state your home address.
Hi, Jason LeBlanc, 3 Cedar Drive. First of all, these monitors are awesome. They're way better than the screen, so this is great. I have to kill my neck. But nice presentation. Thanks for putting this together, guys. Did have a few questions. So just for posterity, because I think the townspeople is the first time seeing it as well as us, just understand. So there were multiple ways to come at it. This is one potential way. It is in a bowl. Could the bowl be raised up and then the fields pitched and then bring the water to the current drain? I think you're saying, John, that that's not the best solution. Is that correct? So we don't want to put the water from the field into the existing drains. I think that's what you guys are saying.
The existing drains, the pipes are quite small. They're very high in elevation. We look at the dry wells.
John, if you don't mind, would you please?
Those drains were added
And I mean the street drains, by the way.
to the street drains.
Yeah.
Yeah, the street drains come from a great distance and they're quite flat.
To your question about raising the system, we do need to get down to the native soil to get that infiltration rate. So whether, if we were to raise the fields or whatever option we choose, we still need to get those chambers down to that depth to take advantage of those native soils.
I think that would be true only if we're using the chambers to handle the water. So the other way to do it would be to pitch the fields, run drains along the perimeters of the fields, and run those drains to the road storm drain, so there would be no chambers, but that means then that the road storm drain has to handle all the water from that field as well as everywhere else. And I think what I'm understanding, and again, I'm doing this for questions later coming on, is that collectively the engineering crew thinks that it can handle that. It can't handle in the field. It's certainly not going to handle it from the road, so we're going to put it in the ground. Do I have that correct?
You're correct. Based on the history of the flooding that we're seeing, several of the drains do overflow to that roadway system, and we believe that is the reason why it's just not draining it. that the roadway is backing up into the site. When you look at where the roadway catch basins and drainage, the surface drainage are, the field drains in that low spot are lower than the road. So if you can imagine that roadway system, water is building up within it. It's probably filling up the pipes and close to the top of grates. That's gonna back up all the way to the end of the system, which is lower. Usually a storm system gets higher the further you go, but it tends to, it's within the site, it's lower than the road by a few feet.
Thank you. Yeah, I think that, please do that so people ask questions. So if I understand it, then the engineering is proposing that we use a system of these subterranean chambers to capture the water. If I understand correctly from this drawing here, you guys are keeping the fields flat and then putting more pipes in the fields to direct the water to those chambers. If we pitched the fields so that the rain would run off naturally and then had more pipes on the perimeter, it still ran to these chambers, could we reduce the number of pipes in the field and still get the runoff to those chambers, or do we have to run this number of pipes at the pitch you showed, 13 and 6 feet, to get it to those chambers? Because I think pitching the field should be done as a matter of course anyway for the fields, but I'm just curious.
Right, so the spacing of the pipes, we have our, we have a flow chart that you saw earlier, and that was really that really guides you on how to space those. And it's a combination, it's not just the pitch, it's your soil makeup, root zone and subsoils, as well as pitch of your surface. And so, yes, option 1 and 2, we wouldn't really be able to change those grades. Option 3, we have the ability to change those grades greater because it's full reconstruction, which then we would be able to get greater pitch and reduce the amount of storm drain infrastructure, the under drains within the fields themselves.
For option 1, I understood it to mean, and correct me if I'm wrong, that you guys are gonna, through a series of processes, add sand and seed, allow it to grow, and could raise the height of the field, is that correct? Through that process, could they use that to pitch the fields?
No, part of that process is correcting any, the thing is you're raising with sand. If you raise with any soil besides sand, you have the potential for smothering out your grass. So you're utilizing, you have a good stand of grass out there, so we're utilizing that good stand, and the crowns of the grass will continue to grow up with that sand.
All right, thank you. Sorry, I have a lot of questions,
Go
but
ahead.
I know people are gonna ask them. Where's the other one here? On the last one, which is a very long timeline, can you help everyone understand why that one is so much significantly longer than the first two?
The last one, it's the most invasive. We're full depth reconstructing everything. The construction timeline is similar, but it's the growing period that makes it a lot different because of that. So, for instance, if we put it out to bid now, it starts construction in spring. You seed this fall, so fall of 26. It grows in fall of 26, grows in fall of 27. Grows in spring of 27. Then you play on it fall of 27. So that's the extended period. Whereas sod, you can start construction now, lay the sod in the fall, and be on it by the end of the fall probably.
So ready full-time next spring.
Correct. So that timeline, that's why we gave a range in months, and that can compress significantly with sod.
Is there a price difference?
Yeah, we visited that a couple times, and it's not linear. We'll provide a revised cost for option 3 with sod.
Thank you.
That's all the questions I had, thank you.
Jason, I don't know if you would know this number offhand. Do you remember, and maybe BJ would know, but one of the two of you I assume would know, the amount of days in the last, or amount of playing days that you guys lose per year? I know at one point I thought we had some data on that, but I just don't know if we do.
We did, and this is from several years ago,
Yeah.
but we lost probably depending on the year, upwards of 2 weeks.
Worth of day, those are individual
Worth
days.
of
so
days.
Yeah.
Mainly, WISC was the biggest perpetrator of this, because after a big rainstorm, and we get them spring and fall, for a day or more, we can't use the fields for safety reasons, because it's so mucky that the kids twist their ankles.
Yep.
So that's it, which leads me to one of the questions one of the gentlemen, people asked here. So if we get fields that are better draining, one of the questions was, why would we pay more or less money? If it's drier and we can play after it sooner, then it doesn't damage the field, right? So right now, if we play on the fields too quickly after they've dried out or drained, what happens is, because we have so much activity, it tears up the fields. And then now the maintenance crews have more work to do to grow the grass and stuff like that. So we're putting more of a burden on the maintenance department to maintain the fields, as opposed to if we can get them to drain quicker and get drier faster. So
Got
I
it.
don't know if you guys would agree with that.
Yes, in the sports industry world, there's a saying, and don't quote this, I think I got it mostly right, but that 1 hour of play after a rainstorm on a field will basically ruin the soil structure and cost you $30,000 plus whatever it takes to fully renovate the field. And you will never recreate the soil composition without going through full reconstruction.
And just, I'm sorry, and then we'll go back to public comment. What happens to, and I think Mr. Maley may have been getting to the same question, when you dig down in those areas to put the chambers, what are you doing with that soil that you're excavating, that the chambers are replacing? Is that just going away, or is there some type of use for that?
Export.
Export, okay, cool. Okay, other members of the public? BJ.
Hello, I'm BJ Treese. I'm at 7 Twin Oaks Drive. I'm also the president of Cromwell Chill Soccer Club. Thank you guys for coming in and doing this work for us. We really appreciate it. This is an extremely popular thing among our user group. Our families are very interested in this and would definitely, even though some of these timelines are a little, are friction creating, they would be willing to allow that friction, knowing that we got out on the other side with a better set of fields to use going forward. So that aside, I do have a couple of quick questions. The first one was our user group in particular, and I think all the user groups are growing pretty substantially. Can you talk a little bit about how these different options fare if the fields are in use for 2 hours a day versus 4 hours a day versus 6 hours a day? Because I think we're getting more and more interested in having more and more use over time. So like, does option 3 significantly change 6 hours of use versus option 1?
Well, that's a loaded question. So we do a lot of town-wide athletic facility studies, and we evaluate how many hours of use are on each facility based on practice, games, tournaments, whether it's cheerleading, band, football, all the different sports, as well as big top circus, everything. But regardless of what system you use, we have a range. North Carolina State University put out a study on how many hours you can put on fields, on natural grass fields. And it ranges from, there's 4 different levels. One is like your game day field. It's like the picture perfect field. The second option is a good field, average field, and not great conditions. And the more hours of use you put on, the more susceptible people are to injuries because of rutting, wear and tear, not even playing surface, not a good standard grass. So we shoot for municipalities at that good range, knowing that you don't want to maintain a game day field. It'd be great to, but it's very, very costly. We don't have an NFL budget or a Premier League budget. So that being said, we have a range of 400 to 600 hours per field that you should be putting on these fields before you start seeing increased levels of poor performance on a conservative side for planning, and natural native fields, we tend to say that 400 range per field. But if you have a more, an engineered sports field, it's more towards that 600 hours of use per field.
Can I just
that's
ask
a-
you?
that's-
Is that per, yeah, what is that per?
That's annual use.
Okay, and does that, you're assuming, are you assuming, that that is seasonal from, I don't know what, May to October, or, you know, so it's not divided by 365, it's divided by 200 or something like that? And to get the number of days?
The number of days, it's based on your seasons.
Right.
So it's usually, it used to be end of March that people get on, but realistically, it's April through June and mid-August for preseason through, depending on how good teams are, but end of October because of daylight savings.
But what I'm trying to say is, I understand 600 hours.
Yeah.
How many per day are you saying?
You could put that 600 hours in, well, there's only so many practical hours per day. Right, so it's a full-on study that you'd have to, like, see when does school close, when are parents arriving, how many waves of people you have of practice per day. Are you having multiple teams per field? There's a lot of different elements that go into that.
I understand that, but I'm saying, from that's our problem as to who's gonna get access when. But from a land use end, your end, when you say 400 to 600 hours, I assume it makes a difference of whether if it's 2 hours a day for 365 days, or if it's 6 hours a day for 100 days, or does that not make a difference?
It depends on how you want to bank your use. If you want to do
From your end, does it make a difference to the land, not does it make a difference to us?
Yes, it does. That's what I'm trying to get at. So if you use all 600 hours in the spring, because you have lacrosse, baseball, softball really doesn't play into that. It's really rectangle sports. You have soccer, lacrosse, and those are really the two main in the spring that you're competing against. But teams are really going to 10-month seasons, so you're not only playing in spring and fall. Traditional seasons are kind of going away, and as youth sports are getting more competitive. So what I'm saying is, if you have that 600 hours of use in the spring, you have to rest the fields for the full fall. If you spend 200 hours in the spring, well, you could use 400 hours in the fall.
You don't get any benefit from evening it out. If it's 600
Well, it's
hours,
less
no
wear
matter
and
how you.
tear, so you'll have, if you put 600 hours on the field in one season,
Right.
at the end of the season, it's gonna be beat to you know what. It's
Right,
just
well,
gonna
that's-
be worn it's gonna be worn significantly. That's why you have a recovery period the following season.
Right, but what I'm trying to get at is, if you did, I don't know, 3 hours a day continuously to get to 600, or you did 6 hours a day continuously to get 600, it doesn't really matter in terms of the annual usage of the field. You get to the same result either way.
Yeah, it's just how quickly you
Okay.
get there.
Okay, thank you.
BJ, other questions from Chill Soccer's perspective?
Yeah, thank you very much. I to make a real example out of that, like if we use 300 in spring, almost very light use in summer, and then 300 again in fall, that's the same as using 600 in the spring and then not using it all in the fall. Okay. Very good. My other one is a little bit more of like a creative question, so if you'll indulge me for a second. Imagine we're 5 years in the future and we've done one of these options, and we're staring at like an inch of water on the field. Like, what most likely went wrong in each option is what I guess like, what's the most likely fail point of each of these options?
That's a great question. I love that. Because and just for context, I know that there are going to be our Facebook experts out there with their measuring tape and the receipt, their tax bill, waving it at us, telling us what went wrong.
Why did we do work with our neighbors? One of the biggest issues, and we see it all the time, especially at school sites, is the athletic facilities are used as a construction laydown area, and they're never ever repaired back to what a sports facility or a sports field should be repaired to. They get over compacted, etc. So in this situation, you already have the existing condition. So it's really quality control during construction. We try to write our specifications to have certain qualifications through American Sports Builders that you get accredited people that build it, but it's the low bid environment. So that's one of the biggest challenges. And the amount of oversight you put on a construction project. If you have periodic construction with someone observing once a month, well, what happens in between those 30 days when someone's not observing versus full-time inspection where you're seeing every day what is happening and you have control of the materials coming on, you're doing testing requirements, etc. But it's also a balance of cost too, because having an engineer out there every day for 6 months during construction adds up. So it's a matter of working with the town to understand how much they could oversee the project and how much they would like the engineer to oversee the project during construction. So some of the things are over compaction, not putting in the right soil mixtures, putting in wrong types of drain pipes, not putting drain pipes in at all, like on 84 a while, maybe 7 years ago, 8 years ago. So things happen when people aren't watching.
So just to go back to BJ's questions, inch of water on option 1, inch of water on option 2, inch of water on option 3. What went wrong? Like, what would have to go wrong for that to happen under, assuming, the system's working as it is, what would be like, we're just trying to stress test it, I think is what BJ's asking about. Like, is it if we get a 100-year storm, option 1 can't handle it, but option 3 would? Like, is that, like, I'm just trying to gauge.
I don't think I would see the 1 inch of water unless there's zero maintenance done after the fact of construction.
Under any of the options?
Under any of the options.
Okay.
Just because you put in a new field that's engineered doesn't mean you don't have to maintain it.
Got it.
You still have to do your cultural maintenance practices of core aeration, decompaction, overseeding, like all of those agronomic improvements are always needed no matter what option you do.
Is there any guarantees with it?
That's what I was about to ask. Is there a warranty? Is there a certain period of time after the construction's done?
You see the brake lights.
It's really a like your standard 12-month warranty that you put into the specifications. And it would be a matter of maintenance too. So if you're having a contractor maintain on an annual basis and taking care and nurturing the fields, I would guess that they give you a warranty. If the town takes over control of the site and the maintenance isn't followed, then I don't think you can warranty that.
I want to go back to public comments, and then we can ask more follow-up questions after. Other public comments or citizens' comments? Mr. Kanata.
How we doing? Mike Kanata, 136 Nooks Hill Road. I'm assuming all your engineering is based on the groundwater level that you know is in July of approximately 7 to 8 feet. Is that correct? So, I'll make it easy. So, July is typically approaching our lower groundwater levels. I built a dozen or so homes a quarter of a mile from this site, and I can tell you that I have found that the groundwater level to be substantially higher than 8 feet. We actually had to raise foundations out of the ground additional 2 to 3 feet in the areas that I built to keep the basements dry. So my question is this. Before you start construction, would you do a much more comprehensive groundwater level study in this area? And if and when you find that the groundwater levels are substantially higher, as I think they are, is that going to affect the engineering and the price, or are we pretty much married to what you have regardless of what you find for groundwater level?
I think this will be a two-part answer. I see Joe stepping up to the plate. That's a very good observation, and we're at the feasibility study stage. So we go with the information that we have in our hands, and that's one of the things that we identified early on is the timing of the groundwater. So we're making assumptions now, and we'll have to follow up with further test pits to during that seasonal high groundwater to understand that the actual depth.
So if you find that the seasonal groundwater is substantially higher, are these numbers going to change, or are these numbers okay if you find that the seasonal groundwater level is actually 6 feet and not 8 feet?
We will revisit. We do, because of the preliminary nature of planning, we have a very good contingency on it because we don't have a full understanding of that groundwater. So it should be, but during the design process, as we get those the groundwater identified, then we'll adjust the grade. So as we understand more about the project, we refine our design and the contingency level goes down, so hopefully it won't exceed the numbers currently that we have on the screen.
Okay, and assuming that the groundwater level, thank you, assuming that the groundwater level is going to come up during its seasonal highs, is the construction and use of the galleys, I call them galleys, is that going to change the amount of storage? If the galley has 2 feet of water in it, and you said it's approximately 8 feet high?
Here you go, Joe.
It's a very good point because we do have existing dry wells, and we'd like, because we're coming into the wet season, which is February through May, we have the ability, without digging test pits, to actually measure down through those dry wells and keep an eye on it. Again, it does fluctuate. It's not you're gonna catch the highest point of it or the shallowest point, depending on how you look at it. But it's a good point to monitor it and check it to see where that highest point of groundwater is. And we can raise the system. We don't want it to be in the groundwater at all. Okay. We can raise it and go laterally. So we don't have to go as deep with the trench and chamber. We can raise it and go sideways, and it'll be a lower profile, but you'll get your storage horizontally rather than vertically. We don't want to be in the groundwater. We want to be just above it. We want the ability of the system to drain, and we don't want it to sit there for very long periods of time. So that's a very good point. Whenever we're designing these, groundwater is a difficult thing to identify and observe. So with the dry wells that are there, we have access to it through the wet season.
So talk to me in numbers. Does the number change or not?
It shouldn't, because if we can get the same volume horizontally as we do vertically,
With a different galley.
right, it's the same amount of storage or volume that the chambers and the surroundings don't have to take up. We won't get it, we may not get it lower, but we can get it horizontally.
Thank you.
Thank you.
Other citizens' comments? I thought you were walking out the door, and I was like, oh no.
That's awesome. Hi, my name is Darren Stiles from 1 Shady Lane. So I just wanted to quickly comment and echo what was said before about increased use of fields. So I'm involved with Cromwell Chill Soccer Club. I'm the field coordinator, so that means that I handle all the scheduling for the games and the practices. All the coaches funnel those requests through me. I make sure we don't have conflicts. And unfortunately, when I receive emails from the Parks Department that the fields are closed due to the weather and due to the standing water, I have to relay that to the coaches each time. I'm also a baseball coach in town. I've been doing that for several years as well. So highly involved with Little League, where we know there's some softball and baseball fields involved with this discussion. Increased use of the fields, definitely seeing that, so I just want to echo that quickly. For example, there's an adult ultimate frisbee group that's been requesting access to the WIS fields, so that's on top of what we already mostly all know with our youth athletics, both travel and recreation programs. And there could be more down the road, right? When the fields are not being used by one of our youth teams or programs, why not allow others to use them as well, right? One question I had was there any research done to identify an alternate site for soccer, baseball, and softball while this is being worked on? Because it's hard to imagine any downtime given the fact that I'm not aware of other fields that I could move practices and games to right now, unless, you know, maybe Rocky Hill's got some fields we could borrow from our neighbors.
Yeah, I don't know if the engineers would have an answer to that one. I think that would be more on us, on the town, yeah.
Okay.
We looked at the possibility of either renting or leasing. We would have to construct the fields then, and with or without irrigation. So it would cost also quite a bit. It'd be nice if we could purchase some additional land and develop additional fields. That would be ultimately the goal. We did try to see if there was a possibility of one individual selling some land, and that didn't work out.
I like the farm over on Gear Street that was in play for that warehouse. Maybe
That's where it
building.
didn't work out.
Future Cromwell Athletic and Recreation Complex.
About 200 an acre.
How much is it an acre? 200,000 an acre. And we'll start bake sales. Go ahead.
Josh Benson, 36 Chelsea Drive. I just got one quick question. We talked about grass and everything like that, but we do have two softball and baseball field there. If we're going to be raising the outfields up with sand and pitching them, what's going to happen to the infields? Are you guys bringing fill in? Because the crown of the infields has to be higher to pitch to the outfield, right? And then that has to drain through, because if you're raising all the grass around, then those become a bowl, and then now we have mud pits. So is that part of the proposal as well, is to raise up the infields too? So you're going to bring in fill, regrade the infields and all that, plus pitch those into the grass? That's my question.
Thank you.
So as part of option 3, the full depth reconstruction, that cost does include regrading of the infield. You would have to bring it up, and you apply new infield mix to bring it up to where you want to be. Option 2 also, I believe, carries that, because you're going to be stripping and disposing. You're going to be regrading the top. You're not really regrading the subgrade. You're really just doing the top couple inches. Yep. So it does carry a minor regrading of the infields for option 2. Option 1 does not.
Okay.
Because you're just adding to the mix.
Okay. So maybe this is to the town now. So we have to really take that in consideration, because that's a major flaw already on our baseball and softball fields, which we just spent money on, one of them redoing it, right? So that pitch is correct. So option 1 right now would not work for the baseball and softball field. So the engineer right now is saying option 2 is a possibility, and option 3. So we would have to really weigh that in, or we would have to make an alternate with option 1 to bring fill in to raise those infields, correct, possibly, and pitch those correctly to the outfield, and then, because you're going to be raising that outfield up, right?
So can you address that under option 1? Does that create a new problem with the outfield and infield for those fields 4 and 5, or can you just verify that? Because then that would probably be, we don't want to solve a problem and create a new one.
No, I should clarify that. So when you're adding the sand to the outfield, option 1 does incorporate, you're going to have to regrade your infield as well. Let me see. I believe I have the cost estimate with me. I don't have it available. Okay.
If you could supplement an answer for us, a follow-up, because that's a really important question.
It was addressed. I want to get you a clear answer on it, but I believe it was addressed.
Yeah, it's a great question. Thank you for bringing it up.
Yeah, just on a follow-up on that, the infield mix, if you recently did a reconstruction on that, we could take a couple cores to see the depth of that infield mix that you put back down. You probably know off the top of your head. But we always could add the infield mix to the top, and then you blend the grades to the outside towards the fence line.
I was just wondering if that's in the proposal.
Yeah, we'll verify that. It's a good observation. Thank you.
Okay, other members of the public. And I want to thank all the members of the public for their outstanding contributions so far, and I'm sure it will continue.
Hi, I'm Abby. I live on Woodside Road, so I kind of have two lenses to this. I coach for Chill as well. I have two daughters that are involved in the Chill program, and who had the pleasure of standing here to receive your accommodations after winning the state cup, so thank you. Couple questions. One being a little self-serving for our neighborhood. In January of 2024, we had unprecedented flooding, so to speak, in the Leghorn Lane area, the Woodside Road area. So we were pumping basements with like 4 water hoses at the same time for days on end. My question is, with the drainage that's set to go, or not drainage, the storage that's set to go around the perimeter, given the water table levels. I think July, I remember seeing the studies being done in July and going, oh God, if they could have only been here in January, that would have been a lot more helpful. I have pictures on my phone where the flooding is more massive around the kick wall, around the softball and baseball field areas. So I guess my question is, what does that do to the potential surrounding areas and neighborhoods and properties on Woodside, to your point with the groundwater level for properties that even you've built in the area?
Great question.
Yeah, what does that look like with the infiltration rate and potential, because now we're putting it around the perimeters of the field, which is great, I'm all for that for one cause, but the next cause selfishly is, what does that do to surrounding properties?
It should not affect the properties or raise the groundwater that far to the adjacent homes.
To that question though, right now, and then I'm sorry, I'll let you finish. Right now, to a certain extent, the water from the fields is infiltrating into the I'll call it the WIS neighborhood drainage system. Would this chamber system eliminate, even if it's like a 10% addition, eliminate that overflow into WIS? Because you were saying some of the pipes already feed into that system.
You're talking, it will relieve the system that's in the road.
That's what I'm asking.
That's correct.
Because part of her concern is not putting on her other hat as a resident. Their systems are getting backed up right now, and potentially what's happening. I mean, part of your assessment was some of the pipes are feeding into that system currently, and they'll be diverted. So even if it's 10% flow somewhere else, that 10% is being taken away from her neighborhood system.
From the roadway drainage system.
Got it.
Correct. Is your concern have to do with the groundwater on the properties?
Yeah, both. So yes, that as well.
Yeah, so it'll create relief to the roadway system. It won't rely on it, but it'll store it. It'll have the volume, and it'll slowly infiltrate. And that gradient of the groundwater is not going to increase all the way back to the neighborhoods. It's not going to be that much runoff that it's not going to raise it's not going to be that much runoff to raise the groundwater elevation of the surrounding properties.
So I guess my follow-up question to that would be, what would be the projected perimeter that it would impact? Because we're literally directly, if I could show pictures, but we're literally within 30, 40 yards of the actual flood areas that currently exist, and where the pipes would, or the structures would be
Just
placed.
to understand groundwater, it's constantly moving in a direction. So it's gonna not raise the groundwater. It's gonna stay in place until the groundwater allows it to move. It's gonna follow the groundwater. So it's not gonna elevate it to the adjacent properties. It's not gonna create It's gonna mound in that location, but it's gonna relieve itself as the groundwater moves. So it's not gonna extend to a point where it's gonna affect your property.
I think the problem in January though was the groundwater wasn't moving because the drainage behind where, like Horn Lane, et cetera, was just pooling and it wasn't moving anywhere. So I think, I just want to express that that is a concern. I know, neighborhoods that had never pumped before and houses that had never pumped before had to rip out basements and totally redo things. We put in 4 sump pumps to our home to the tune of about $12,000. So.
To truly answer that question, there'd have to be a full hydrological test and study done to truly answer that question.
No, it's good. Thank you. Appreciate it.
Just one other plug for the fields off of Gear Street. And just because we have the ear, be a wonderful opportunity for the town to reach out to other neighboring towns who are already crowded with field capacity as well, and offer potential revenue for the town, as well as local clubs that seem to be expanding, multitudes of teams over and over again that are craving for field space with both, I believe, softball, baseball, and soccer field.
Yep.
So just another plug there.
Yeah, no, we definitely need the additional capacity. And, part of the discussions we've been having, just so you know that we're actually thinking about it, is, how much would it cost to purchase those pieces of parcels? And then how much do you then, after purchasing it, need to put in to make them usable? So no, it's something we're definitely like big picture thinking about, but I didn't think about asking other towns. Maybe Rocky Hill will go halvesies with us.
Thank you very much.
If we rotate
Could you
weekends.
just restate your name and address for the record?
Yes, mine is Abby. I live at Woodside Road. So thank you.
Okay, any other citizens' comments? I'll ask again, any other citizens' comments? Okay, any other comments from the commissioner or board members or council members? Matt, go ahead and just share the mic right there.
Sure, thanks. Someone had quoted before, I think the amount of downtime at the Wisp Field, you said, I think it was 2 weeks. Not sure if it was Jason or if he's still here. Oh yeah, you said 2 weeks. Just for perspective, that's 2 weeks, so 10 days or 14 days call out of like a 12-week season or what? Just for context, like percentage.
That would be a season. So in some seasons, if it's dry, it could be, a few days if it's really dry. In some of the seasons where you have a lot of rain, we lost 2+ weeks in just the spring season. And then in the fall, if it's rainy, we can have 2 weeks in the fall season. So it really depends.
So like up to 20%, I'm bad at math, wait.
Yeah,
20%
because we only
of your
go
season.
from early April until June. So we have literally 6 weeks. So if we lose 2 weeks, then these two guys are pulling their hair out because now we're rescheduling games and calling up towns, right? Yeah.
Just to add to that, it's not like 2 weeks straight, right? It's like, right, yes.
I'm just saying, like over, I'm not sure if your seasons are
Yeah.
2 weeks or 14 weeks.
Yeah, they are typically like 8 to 10 weeks long, and it seems that our luck tends to be that we get rainstorms on Friday and then we can't play all weekend. This just seems to be the luck. But so yeah, it's 3 days here, 3 days there. It tends to impact 3 to 4 weekends of games out of a 8 to 10 weekend season. So that's a significant portion of our games.
Thank you. Go ahead, Jason, and then I'll turn it back
to
over.
follow up on Mr. O'Malley's question about hours. If we assume 5 hours a day of usage and we do at least 3 hours of practice starting from 5 until 8, and the school uses the fields during the day for recess and practice, so 5 hours a day times 7 is 35 a week, times 4 is 420. If we're assuming from April to November, we're in the 1,200 hour range. So we're over the 600 hours we're talking about. Now, of course, we don't use them that much in the summer, so those months it's a little bit less. And, game time on the weekends, we use them Saturday, Sunday, maybe, 3 to 6 hours, depending on the number of games for those fields. So it gives you an idea where we're at.
Hearing any other citizens' comments, just one last chance for people to get a bite of the apple. Okay, hearing none. Any other counselor or board member comments? Okay, hearing none. Oh, go ahead, Mr. Malley.
Well, I just said the only one is what's our plan?
Yeah. So I think with this informational hearing done, The next steps will be the council and then in turn, Board of Finance need to come up with a strategy about if we want to pursue one of these three options, which option we want to pursue. Depending on the dollar number associated with it, there's different pathways that it has to go to. I don't remember what the referendum trigger is. Is it $1 million or is it a percentage? It's a percentage, okay. Do you remember what the percentage is?
1% of the total.
And so what's, it's gonna be referendum, right?
Yeah.
So we would have to go to referendum. So it sounds like regardless of which option it is, probably gonna have to go to referendum. So we would have to follow our normal referendum process, and then the secondary question is, do we want to do this through, normal capital expenditures, which would wipe out our annual capital expenditure? We wouldn't be doing anything but the field. Or do we do it as a separate, do we look into bonding and we go out to bond on it? I think we would have to dig into how we pay for it more substantially. But I guess the consensus that we have to reach probably at the next town council, next Board of Finance meeting is, do we want to go down that road? Or is the $1 million to $3 million better spent purchasing and building a new field from scratch? Or is it at all, try to do both? I think we have to, we needed the information before we could figure out what pathway we'd go down. What I'd suggest is everyone in this room think about if renovating the field is the way we want to go, what level of commitment do we want to have to it, and then start to think about the prep work needed for a referendum on any of the three options, and figuring out on any of the three options what we can afford. We'd probably want to go to bond council and say to bond council, 1 million, 2 million, 3 million, what's the mill rate impact on both? What's our ability to borrow on both based off of the fact we just borrowed $40-something million? How big of an impact, how much can we swipe on the credit card at this point without hurting our long-term prospects? And I know we've done that math recently, but so I think the next part of the discussion is, do we want to keep going down the path? If we want to keep going down the path, we need to get more answers to more questions and then go through the normal referendum process. Mr. Kelly.
James, two questions. One is, so I've heard feasibility. Mike, has some really good questions regarding table, water tables, where that needs to be. Thank you. Does feasibility change not just the numbers, but does it change the options that are available to us? In other words, do we find something in the next 3 months that said option 1 is not a non-starter? You need to do option 2 or option 3 at this point before we go to a referendum.
Yeah, no, we
put
would
something forward.
We would need I think we would need to do design work, appropriate money for pick an option, do design work, and then I think we would go further. But I'm not. Okay. I'll ask Tony what would be the next steps as far as what we would need for a referendum. Would it be we need to pick option 1, 2, or 3, and then do the design work and drill down on it, or is it how do you drive the car here?
I would recommend design. What do you say, John?
It's a great question, Dan. Thank you for asking it.
So these two bodies allocated money for this study tonight, but also allocated money for a design. It's a design of one of the three options. So, there is some benefit to getting a shovel-ready project. In my opinion, this project might be eligible for state bonding. We were successful a few years ago. We got $2.25 million, which was split between improvements to Pearson Park football as well as a sidewalk out front. So, my recommendation would be to continue this process and get a shovel-ready project, whether it's 1, 2, or 3, so that whether it's some grant monies are out there or not, or if it's a town funding option. But otherwise, we're asking these gentlemen to tread water for a minute.
Yeah. So your suggestion, John, would be the council and Board of Finance pick a lane, 1, 2, or 3. We already have the money appropriated for designing it. They finish designing it. We then, take our shot at trying to go bond money for it. If that's not successful, then referendum. But we as a council and Board of Finance, you're suggesting, need to pull up one of the 3 levers, and that's what the public would vote on ultimately at a referendum.
Right away, these numbers are going to be subject to inflation, but there isn't going to be anything that radically changes,
Sure. Okay.
So there's nothing in the feasibility work that's going to be done that would change what option would be available to us. Is that what you're saying? And that's my question. My question is basically, we're going to go back and look at this stuff harder when we start designing. Do we find something that says, I would not do option 1 or
groundwater. I think that we should verify that groundwater. It's within the next month or two here to verify those depths during the seasonal high, and then open up pits, a couple of pits, not going crazy out there and ripping up the fields completely, but a couple pits to observe the modeling of the soils visually versus a boring, you only can see so much information. So opening up the ground has proven to be very helpful.
So we're getting close to our time, and Board of Finance still has items that they need to debate. So,
Jason, can I just ask
yeah.
one more question, more directed to Tony? So we're talking about property. What about the property that we own already? Have we approached the state on opportunities to change the structure of that property from open space to something different to allow for?
Which property?
Millbrook Road. I mean, we own the farm.
Oh.
We made a decision
yeah.
a lot of years ago.
Maybe Mr. Maley can help us there, because when I first became town manager, I made a call. John Harriman has the number of the person, and I asked if we could actually buy our way out of the restrictions and pay back the $400,000 that it cost the town back then to get I think $1.5 million or something, if I remember correctly. And it was not received very well, and I was basically told in no uncertain terms that that was not allowed.
I would agree, that is, I'm not aware of any situation, where the only, I guess there's one or two situations where there's been a property swap, but none where it's a monetary thing. And even those are quite rare. So it's not generally looked on favorably.
Okay.
It would have been nice.
And just real quick before the deputy mayor, because we need to, it sounds like, make some decisions relatively soon. How long until we can get an updated drainage study to see if that impacts the feasibility of option 1, 2, or 3? Because if you do if you get the new borings at the seasonal high of late February, early March, whatever it is, and you say, whoa, the water level's really only 5 feet deep, option 1's no longer an option because of X, Y, and Z, you're gonna have to raise it if we are gonna bury 6, whatever it is. How soon can we have that information to be able to pull the trigger on one of these? Reasonably speaking. Because every time it rains, I get chest pain every time it rains in this town. So I'm just, how much chest pain am I gonna need?
We'll follow up with an answer on that.
I love it, thank you. Deputy Mayor, last word.
Has anybody looked into for possibly grant money? Because I know there's a lot of things that the town has gotten grant money for, and I know we haven't got hit yet with the taxes for the new school yet. I know it's coming down the boulevard. Just if we could get some grant money, I think it would make things change a lot, make things look better than what they are right now.
We'll explore every option that we have. I can say that with confidence. Okay, so with that, I know Board of Finance still has some business to do, so I will, with that, adjourn the town council meeting at 6:49, so Board of Finance can finish their business that they have before the 7 o'clock planning and zoning meeting. So, good luck. Thank you.
Under the gun.
Thank
Here we
you.
go. Can I have a motion for possible approval of Steve?
Hold on one second, sorry, John. I need a motion to adjourn. Motion made by Brian, second by Paula. Any further discussion? Hearing none, all those in favor, please indicate by saying aye. Aye. Okay.
Can I have a motion for possible approval of Steve Wagonowski as the Board of Finance representative to serve as a regular member on the new Public Asset and Facilities Committee? Moved by Mr. Blanchett, second Mr. Kelly. No, he had to leave. Yeah, so it's gonna be the four of us. So, so very quickly, I know this is a new new committee that has come on board. I think, as you guys all know, Steve has done you know, a lot of work with his spreadsheet and analysis and assets and all that kind of stuff. And so I know he's expressed a real interest in being on it. I'm not necessarily saying we shouldn't talk if others have showed an interest up as well, but I know Steve has kind of taken the reins on this so far, and I think he'd be a good fit for that committee. So I know Steve isn't here tonight to speak to it. I believe we want to have the vote tonight just because I think that board and commission is looking to try to get moving and going. So if there is discussion, or if there is someone else that does want to have, you know, some, you know, interest or discussion in it, we can certainly talk about it. But, you know, I wanted to put that out there. So, discussion? All right, all those in favor signify by saying aye. Aye. Raise your hand, I guess without a mic. Okay, motion carries. Second, can I have a motion for discussion and possible action to approve an appropriation in the amount of $200 from the general fund balance for the Cromwell St. Patrick's Day Parade Committee? Moved by Mr. Blanchett, seconded by Mr. Kelly. So this is something that came out of, the deputy mayor's still here. This is something that came out of the last town council meeting. I believe, I think I emailed out some detail just around supporting of this project. And the town council decided to get behind it, and so it came before us, I guess, with obviously the timing of this and their last fundraiser, which is the middle of February, I believe you said, Al, right? We wanted to get this in before our next scheduled Board of Finance meeting. So, $200 to support the cause. I obviously open it up to discussion.
I'd like to ask a question. It's our 9th year running it. In the past, have we just been able to organically generate enough donations? Yeah, in the future there'd be something that's just in our budget. I know we have $100 for this club.
Yeah, I think we normally have a few grand for some, you know, different charities and
We have a budget
causes.
page in our budget that's prepared. Unfortunately, they have always been successful in getting the funding that they need. This year, unfortunately, they are running short. So this is appropriate donation if you so decide, and I would recommend supporting it.
It sounds like a contingent donation, right? To the extent there's a fundraiser dinner, so if they raise enough, or they raise enough.
So Tony, you know, there's a lot, I, as a matter of fact, have given to this particular parade myself in the past, but there's a lot of parades. Have we received requests from other parades over the years?
Memorial Day parade.
I was asking the town manager.
We do the Memorial Day parade, and
But the Memorial Day parade is a town function, isn't it?
but they allow the American Legion to be the agent.
Okay,
They put it on, and we
right.
donate funding for that. And I believe LGBTQT plus,
Right.
if I remember right, we give a donation, and they support the Pride Day in Middletown, if I remember correctly. And there might be one other. I'd have
Well,
to
I
look
mean,
at-
there's a variety, there's a Polish Day parade in New Britain, there's a Puerto Rican Day parade in Hartford, et cetera, et cetera, et cetera. You know, they're not in Cromwell. They are ethnic groups that are partially represented here. I mean, I just want to say that if we start this one, I
Well-
assume they will all be happy to take our money in the future.
The only thing I would say is this is the only one that I'm aware of that, over the past years, has shown a presence. I'm not aware of any other groups.
You're not aware of any, when you say showing a presence, what do you mean by that?
There's a number of participation from groups in Cromwell that attend this parade.
Oh, I know, yeah, okay, but I'm
not
gonna
aware-
tell you,
I'm
I
not-
know people who,
Yeah,
you know,
but
go
I'm
to
not
other
aware
ones.
of any other groups that attend, and, you know, there may be individuals
There are.
Yeah, but I'm not aware of any, to the extent that this parade's attended.
I guess, I mean, I'm inclined to do this, but I just want to make it clear that
You're correct.
we're on a slippery slope here. And I certainly wouldn't suggest that this particular ethnicity, which I happen to be a member of, is in any way better than any other ethnicity that might have a parade. So that's where we're headed.
Anybody else? Any other discussion? Seeing none, all those in favor signify by raising your hand. Opposed? Motion carries. Just to be fair to the agenda, we had citizen comments after this. Are there any citizen comments? Seeing none, I was just saying, you're more than welcome. Seeing none, can I have a motion to adjourn? 6:56. Thank you, everybody.